Assalamualaikum, respected panel. My name is Ahmed Ali and my topic for my FYP is about the development of circuitry model for supercapacitors. So for my FYP I used WebLoad Digitalizer, which is an online tool to extract the data from graphs and maps. So here I'm using a graph which I took it from a journal, and for my FYP I took like graphs from 7 different journals for 7 different materials. Here I'm going to align the x-axis and the y-axis. The x-axis is always the frequency and the y-axis is the real and imaginary values. So here I give the values of x-axis, and x-axis is always in log scale and the y-axis is in normal. After giving the I'm going to extract the data from the red line only, and I use this tool especially because it can run by itself. It is an automatic extraction by using different colors. So I used 1:6, which gave me a perfect line, and it gave 400 data points from this graph, and these are the data points x and y axis, and I use 7 digits only fixed and with a spacing in between them, and I can copy this data and take it to Excel. So, and here's also for imaginary point from the same and here is the data 1:6 ratio, and this is from another graph from another paper, and here is a example of paper that I took the graph from. Basically I'm going to make a Nyquist graph from these real and imaginary values. Here are the two graphs, and I took only one line from in there, and this is the second material type from a different journal. And coming to the Excel, now we have the real value and the imaginary value with the frequency. As you can see here, the graph resembles perfectly with the picture, and this is a Nyquist graph where the real value is in the x-axis and the imaginary value is in the y-axis. Now this is for another journal. The real values are here and the imaginary values are here. For the Nyquist graph, in the end I need to make them in one column for the real, imaginary and frequency. Now for my simulation program I use EC Lab, as you can see here, and I'm going to choose this option, electrochemical impedance spectroscopy. So here is the type of model, circuitry model, and these are its values, and this is the method, and I'm going to use it for 10,000 iterations. Now let's choose this, and here you can see there are many different models that I can choose from, which can be used in my graph, but only one or two will resemble it perfectly. And here is the equation of that circuit also. So let's start the simulation. And here is also a picture of the circuit model that I'm trying to simulate in this graph. So basically this is my original Nyquist graph, and the result will also show me another type of a graph. Like it will try to match my original graph with its values, real value, imaginary and frequency. So here I did the simulation for 10,000 iterations, as you can see here, and this is the final result. So as you can see here, it did not really match with my original graph. This circuit model doesn't match with my original graph. So I'm going to, for my FYP, for every single graph I run through with all these circuits. So these are some of the best circuits that resemble my graph. Some of them are like somehow matches and some of them perfectly matches. So here is one more example. As you can see here, it somehow matches with my circuit model, and the deviation is really less. It's in negative power, like such low number. But I'm going to use this circuit again, which perfectly matches with my graph and this model. As you can see here, this is the model, also shows its equations. Then I run the simulation, and down there is the model of circuit, and here is an example. It's really matches with my original graph, and here is the deviation, which is really less. Thank you so much.